Question A, x times x plus 2. So x times x is x squared. X times 2 is 2x. Question B, 7 times x is 7x. 7 times 2 is 14. Question C, x times negative 6 is negative 6x, and x times x is x squared. D, 5 times x is 5x, minus 5 times 6 is minus 30. Question E, x times 2x is 2x squared, and x times 4 is 4x. Question F, negative 10 times 2x is negative 20x, and negative 10 times 4 is negative 40. Here, we're asked to evaluate each expression, and we're given the value of the variable. So we're given a question 3x plus 14 and told that x is equal to 12. So we simply take this x value and plug it in to where the x was, and then we multiply 3 times 12 plus 14 gives us 36 plus 14 for an answer of 50. For this question, 7r minus 3, we're told that r has a value of 9. So we simply take this value of 9, plug it in where r was, gives us 7 times 9 minus 3. 63 minus 3 equals 60. For question C, we're given the expression 24 minus 2a, and then we're told that a is negative 3. This is a little mistake here. This should be an a. So we simply take this negative 3 here, plug it in. 24 minus 2 times negative 3 is 24 plus 6, because negative 2 times negative 3 is positive, for a final answer of 30. Here we're given the expression 15 plus 2k, and we're told that k has a value of 10. So we take that 10, we plug it into where the k was. 15 plus 2 times 10 gives us 15 plus 20, which is 35. Question B, we're given the expression x squared minus 1. And then we're told that x has a value of 2. Now it's a good idea when we're doing these type of questions to always put the substituted value inside brackets, just so that we don't get any confusion at all. So we take that 2, and we understand now, because it's in brackets, that the 2 is being raised to an exponent 2. So that's 2 to the exponent 2 minus 1. That's 4 minus 1 gives us a value of 3. In this expression, question C, x cubed plus 2x squared plus 3. And we're told that x is negative 1. And once again, it's a very good idea to use brackets so we don't get confused as to what's being raised to an exponent or what's being multiplied. So our x value is negative 1. When we put that inside brackets, that's negative 1 to the power of 3. Our x value Here, again, -1. We're raising this -1, this entire -1, to the power of 2, and we're multiplying it by 2. Okay. So this -1 to the power of 3 remains -1. -1 squared becomes +1. 2 times +1 is 2, plus our 3. So our expression is -1 plus 2 plus 3, which gives us an answer of 4. Here we're asked to collect like terms and simplify. So we have 3x plus 3y minus 5x plus 4y. Our like x terms are 3x and -5x, and our y terms are 3y and 4y. So we can collect the 3x minus 5x to give us -2x, and the 3y plus 4y gives us 7y. Question B, our expression is x plus 6x minus 4 plus 3xy minus 1. Here we have like terms, like x values, so x and 6x are like terms, and 4 and 1 are like terms. So we can collect the x terms to give us 7x. Our numeric terms, or constants, is -4 minus 1. That gives us a -5. And the 3xy is just by itself. It doesn't have any other like terms. So it just becomes 3xy plus 7x minus 5. Question C, we have 12g squared minus 2gh plus 7hg minus 3h squared. Now, it might not be immediately apparent to you, but gh and hg are like terms. They're simply multiplied. So it may not look like it right away, but you need to realize that this and this, these are like terms. So we can say 12g squared plus 5gh, or we could have said hg, minus 3h squared is our final answer. Question D, 3m plus 4 minus 4m squared minus 5m. Our like terms are the m terms, so we can collect them and add them together for a final answer of -4m squared minus 2m plus 4. Now when we're arranging these, particularly in our final answer, we try and put the terms with the highest exponents first, followed by the term with single variables, followed by our constant. It's just a convention that we use. It makes it easier for people to read. Determine the factors of each number. So question A asked us to write out the factors of 36, all the numbers that can be multiplied together to make 36. So let's continue in the habit of starting with the lowest number and then multiplying it by whatever we need to get the number we're trying to get the factor of. So we'll start with 1 times 36. 2 times 18 gives us 36. 3 times 12, 36. 4 times 9, 6 times 6, 9 times 4, 12 by 3, 18 by 2. These all give us 36. But negative 1 times negative 36 also gives us 36. Negative 2 times negative 18 and negative 3 times negative 12. These are all factors of 36. Here we're asked for the factors of 40. Again, let's start with 1. 1 times 40, 2 times 20, 4 times 10, 8 times 5, 10 times 4, 2 times 20. These are all numbers that we can multiply together to get 40. And let's not forget the negative numbers. Negative 1 times negative 40, negative 2 times negative 20, negative 4 times negative 10, and so on. These all give us a number of 40. They all multiply together to give us 40. Factors of 32. 1 times 32, 2 times 16, 4 times 8, 8 times 4, 16 times 2, 32 times 1. These numbers here are all factors of 32. All the factors of 24. Once again, we'll start with the smallest number. And here's a list of all the numbers that can divide evenly into 24. All the numbers that can divide evenly into 18. All of the numbers that can divide evenly into 72. Here we're asked to square each monomial. Mono meaning one, so we have one term, and we're being asked to square that one term. So we'll put it in brackets again, just to avoid confusion. So 3x to the exponent 2, or 3x squared, is simply 3x times 3x. We can square the numbers first, or the coefficients first. 3 times 3 is 9. X times x is x squared. So 3x times 3x is 9x squared. Here we're asked to square 5a, so we'll raise 5a to the exponent 2. Again, we'll put it in brackets, just to remind us that it's the 5a that's being squared, not just the a. So 5a times 5a, well, 5 times 5 is 25, and a times a is a squared, for a final answer of 25a squared. Question C, negative 2g. So we're asked to square this entire negative 2 term. Again, we'll put the negative 2g inside brackets and raise that entire term to the exponent 2. And then we can rewrite it. Negative 2g times negative 2g. Negative 2 times negative 2 is positive 4. G times g is g squared, for a final answer of 4g squared. Question D. Remember, we're being asked to square each of these terms. So if our initial term is 4p to the power of 4, we can put that inside brackets and raise that term to the exponent 2, and then rewrite it so that's the entire 4p to the exponent 4 times 4p to the exponent 4. 4 times 4 is 16. p to the exponent 4 times p to the exponent 4 is p to the exponent 8, for a final answer of 16 p to the exponent 8. Determine a pair of integers that meet the following requirements. So we want two numbers that are going to multiply together to be 24, but those same two numbers need to add together to be 10. So to do this, we'll start by writing all the factors of 24. What are the pairs of numbers that can add together to be 24? Well, they are 1 times 24, 2 times 12, 3 times 8, 4 times 6, and so on. So we have all these pairs of numbers that will multiply together to be 24. But one of these pairs of numbers needs to add together to be 10. So we look down our list. Is 1 plus 24 10? No. 2 plus 12? No. We keep on going down our list until we find a pair of numbers that will add up to 10. And this just happens to be 4 and 6. So that's our answer, 4 and 6. And the ability to do this is going to become very important later on when we start factoring. In this question, we're asked to find a pair of integers, two numbers, that multiply together to be negative 25, and those same two numbers will add together to be 0. So we'll start by writing the multiples of negative 25. 1 and negative 25, 5 and 5. Well, these are our multiples. There's actually negative 1 and 25, and we could say negative 5 and 5. But we'll start with these two and see if one of these pairs adds up to 0. And it just so happens that 5 plus negative 5 add up to 0. So that's our pair. That's our answer. Question C. We're looking for a pair of integers that multiply together to be negative 32 and add up together to be negative 4. So our multiples of negative 32 are follows. Here's the pair of numbers. Every one of these pair of numbers multiply together to be negative 32. But only one of these pairs will add up to be negative 4. And that just happens to be negative 8 and 4. So we have to look at our multiples, and we have to look at each one in turn and find one that adds up to negative 4. Then we'll have our answer. And here we have a bunch of lines drawn on a graph, and we're asked to find out what the y-intercept is. So here's line A, and we can see that it crosses right at negative 3. Line B crosses at 6. Line C crosses at negative 4. And line D crosses at 2.